we'll see throughout this semester that much of chemistry is all about measurement, gathering data using instruments and working with it, whether that data be temperature data, mass data, distance, time. We have a lot of different metrics which we can apply towards experiments. And so we're going to have a kind of systematic way of talking about how our units for all of these different metrics will function. And so we can talk about many different types. We can talk about mass units. We can talk about distance or length. We can talk about time, just to name a few, and then we can go from there. So for mass, we have standard units. The standard unit for us will be the kilogram, which is abbreviated kg. And a kilogram is 2.2 pounds, so a little bit more than 2 pounds. It's our standard unit here. For distance and length, we will use the meter, which is abbreviated m, lowercase m. For time, we use the second, which is abbreviated s. Time is a little bit special. We're going to see with distance and length, we don't have necessarily other kind of named units. They will all have something to do with meters, as we will see soon. But time, we don't really we have special special words for time units, like minutes, for example, or hours, days, years. These are a little bit different than the rest of the metric system. We have other ones. We have volume, so how much space something takes up, or we can talk about area, but that's less interesting to us. We have energy. Units of energy are very important, and how about temperature? With these, the units we use for volume, we use liters. It's abbreviated capital L. And again, we will see derivatives of all of these. You can also see cubic meters as a standard unit for volume, because a volume would be 3 dimensions, right? Distance is 1 dimension, so 3 of those. Just so we know, 1,000 liters is 1 cubic meter. That's something you'll want to remember. Or we will see later on, 1 milliliter is 1 cubic centimeter. And so these involve prefixes, which we'll go over shortly. Units of energy will be the joule, which is abbreviated J, or the calorie, which is abbreviated CAL. And finally, temperature, the units we're going to be using here will be Celsius, is got a degree symbol, degrees Celsius, and then Kelvin, which is no degree symbol, but just the capital K. We are not going to use Fahrenheit. Some people like to make you guys go through the age-old routine of converting Fahrenheit to Celsius. I think that's pointless. You've done it in 3rd grade. Let's leave it there. Use your phone. It'll convert it for you. So don't worry about Celsius and Fahrenheit. We don't need that. But Celsius to Kelvin is an important one. We're going to see that that has a special formula. We'll see that our temperature in Kelvin will be a degrees Celsius plus 273.15. So don't forget this. We'll see that when we talk about thermochemistry some more. So that seems to be the theme of this week's videos, is wait until thermochemistry. So with this, that's a pretty good sampling of our common units that we'll see. But we often encounter very big or very small quantities in chemistry, for which we will adjust our units. And instead of having different units like the US system does, where we have inches and feet and yards and fathoms and miles and leagues and all sorts of bizarre units that are based on some drunk mathematicians or something, We're not going to worry about those. The metric system is very neatly organized by powers of 10. And we use prefixes to convey these powers of 10. For example, we're going to see that we have a base unit, whatever that might be. Let's say it's the meter. And we're going to see that we're going to just be increasing in size as we go up. So our magnitude will increase as we go up. Our base unit will be meter. Typically going up, the next one we use is kilo, although there are a few more. You have deca and hecta, but those are kind of less commonly used. The prefix kilo, like for example, kilometer or km, both lowercase, means 10 to the third. So 1 kilometer is 10 to the third meters. As we keep going up, we have after kilo, we have mega. That's the next one we use. We have megameter, although this is not really one we see very often. That would be big, capital M, small m for megameter. The mega is capitalized. Mega stands for 10 to the 6. You might be more familiar with megabytes, for example, in storage space. If we keep going up, we have giga. We could have a gigameter. A gigameter is a billion meters, 10 to the 9th power. Capital G, and then your base unit, in this case meter. And at the top here, there are more, but we're gonna stop here. We have the tera, and again terabytes. So you know many of these terms: mega, kilobytes, although we don't really see those much anymore. Megabytes, gigabytes, terabytes, right? These can be applied to any base unit. So a terameter is 10 to the 12th, or a trillion meters. A terawatt is a trillion watts. A teraliter would be a trillion liters. So we can apply all of these to all sorts of different base units. And we're going to see here that that's the great advantage of the metric system. We can also look at very small things. So a terawatt, terameter, terabyte allow us to talk about very large quantities very easily. We could say, this hard drive is 2.0 terabytes, meaning it holds 2 trillion bytes of data. And that's a little bit easier than saying, well, this one holds 2,000,000,000,000,000,000 bytes, or 2 terabytes. What do you prefer? Typically speaking, we will use appropriate prefixes whenever necessary. So let's get that nonsense out of the way. And let's take a look at the smaller ones now. So kilo, mega, gigatera, those are all bigger. So a megameter is bigger than a meter, right? It's 1,000,000 meters. We can go the other way. We can look at small stuff. We have deci. These are all prefixes, by the way. Prefix here. We have our deci, centi, and milli. And these represent 10 to the minus 1, 10 to the minus 2, or 10 to the minus 3 power. So 1/10th, 100th, 1,000th. You can have a decimeter, centimeter, or a millimeter. The abbreviations dm, cm, mm, lowercase m this time, in contrast with megameter, which is a capital M. And we have a few more going down as well. So we have the opposite problem here. 1 millimeter is 10 to the minus 3 meters. So a millimeter is very small by comparison. All right, we have beyond that, beyond milli, we have micro. So we have a micrometer. This one is abbreviated with the Greek letter mu. It looks like a U with an extra long kind of up tail at the start. That represents 10 to the minus 6. We have nano, like a nanometer, abbreviated N, lowercase n, that's 10 to the minus 9. And then 10 to the minus 10, we have pico, so a picometer. Atoms are along the range of picometers, long lengths between them. Nanometers, that would be light. Micrometers, cells. Millimeters, hairs, although that can be micrometers as well. Centimeters, then we start getting to things we're more familiar with. Centimeter, is about this big. So, meter is, I don't know, about as far as I can extend my arms, so. All right, with these, what we want to be able to understand is that these exponents always go with the base unit. And you'll always put the number 1 with your prefix unit. For example, 1 centimeter is 10 to the minus 2 meters. So notice here we have the 10 to the minus 2 goes with the base unit. And so we have 1 centimeter is 10 to the minus 2 meters. We could say 1 pico watt is 10 to the minus 12 watts. Or 1 gigajoule is 10 to the 9th joules. So all these prefixes go with the base unit. And you have the number 1 of your prefix unit equals your power of 10 of your base unit. So 1 gigajoule is a billion joules. All right, and so let's just kind of finalize that by writing this out. 1 of the prefix unit equals 10 to the x, whatever x happens to be, of your base unit. Whatever that exponent is. For milli, it's minus 3. For giga, it's 9. For mega, it's 6. Micro is negative 6, whatever that happens to be. This will be how I will be using these throughout this course. And so when we talk about converting in between units, this is how I will always do it. And so this is something you will focus on more in lab when you're working with these numbers, converting things between each other. In our next video, we will look at just that. We will look at kind of converting units, but that is something you will focus on more in the laboratory.